Alright, in this lesson we're going to talk about ionization and what is an ion. As we can see here by the periodic table, every element up here can become an ion, some easier than others. Remember, as we've talked about before, we have areas of low ionization, which means almost no energy to become an ion, which would be in this column. Let me turn my pen on here. Would be in here in column 1, and over here in column 17. The areas that are very hard to become ions, of course, are these noble gases over here. And although the larger their size is, the easier it is for us to turn them into ions, such as krypton, xenon, and radon can become ions. As they're smaller in size up here at the top, change my color here, so this one here, neon, and then argon are much harder to become ions. If we take a look at the periodic table, which as we can see here is the actual periodic table in long form, we can see that in this area from here all the way over to here, all of this is called transitional metals. And if we remember from class talking about transitional metals, this entire area here, we cannot determine what the charge is usually. There are some that are the same charge all the time. One of those would be like zinc or silver. Zinc is always a 2+ charge. Silver is always a +1 charge. But in general, many of them can have multiple charges, like manganese right here can have as many as 7 different charges on it. So this area in here, which we call the transitional metals, this area we usually will wait to determine what ion it is by what it is bonded with. Okay, so what that leaves us with is that we have these tall columns here. We have 8 of them. And those 8 tall columns right there are the ones that we can determine the ions very easily. As we can see here, if we just take the transitional metals out and we look at these, remember that every element wants to be like a noble gas. Why? Because its outer shell is full. Full outer shell. That's what nature wants to happen. That's why these are what we call noble gases, are inert. And inert gas means very hard to actually become ionized. The easiest ones here to become an ion then are the ones that are really close to either getting its outer shell full, either by gaining 1 electron or losing 1 electron. Those 2 columns would be column 1 here and column 17. Column 17 has such a high electronegative charge, or pull from the center of the nucleus, the protons, that it does not give away electrons very easily. It will gather electrons and capture them. So this entire column over here normally will only form a plus or a 1- charge. Okay? However, column 1 over here only has 1 electron in its outer shell. If we remember back from our atomic, symbols and the atomic structure lecture we had, so it can easily give away 1 electron and have its outer shell full. And if it gives away 1 electron, that would mean that it now has 1 more proton than it does electrons. So then it's going to have a +1 charge. Consequently, this column here, which we call the alkaline earth metals, they also will become ions, but they have 2 in their outer shell, So what they're going to do is they're going to give away 2, and everyone in this column will form a 2+ charge. We can continue down the line and say that these are generally 3+, these are generally 4+, and right here, let me change my color here, right here is where we start to have some changes. And if we take a line here and we come down and we take a look at this, kind of just go through here and then up along right through here. This area right in here, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, bromine, iodine, and selenium at times, depending on what happens, will all form negative ions. And a negative ion is known as, if you remember from class, I'll change the color here so it stands out, is known as an anion. All of the rest of these, everything from here all the way over here up into an area like this, all of the rest of these in general, and all of the transition metals in general form positive ions. So they are ions that have a positive charge. These are called cations. So ionization is just the ability of an element to go from its classification as atom, because remember, if the term atom means equal charge or no charge, same number of electrons as protons, to an ion. An ion means it either has gained, as in the case over here, gained an electron, or has lost an electron, which is what most of the periodic table's elements will do, is lose electrons to become cations, because now they have more protons than they do electrons. Now, if we take a look at the main periodic table here and we look at the trends of how easily something becomes an ion, the things that are easiest, okay, its ionization trend, if you will, its periodicity, that's why it's called a periodic table, actually goes into a very specific order. The smaller in size, if we take and just drew a picture here and said this was the nucleus that had the positive protons in it, and then out here is our electrons, and every one of these shells has electrons in it. We'll just say we know that the most this can have is 2 electrons, and we know that this can have 8 electrons, and this one here can have 8 or more electrons. The further away from this nucleus here that this electron, so we'll say this little electron that's floating around out here, the further away from those positive pole of those protons, so when that proton is pulling on that electron back and forth there, the further away it is, the easier it is to get rid of that electron. So, elements that are down here at the bottom, such as francium, okay, things of this nature, okay, they are going to lose electrons extremely easily. So the ionization trend would look something like this. It would go up in this direction, okay? The bigger the size, the easier it is to become an ion. The closer it is to the nucleus, the harder it is to become an ion. If we look over here, and we know that over here is the strongest electronegative one, over here at fluorine, we know that its electronegativity rating is so high that it doesn't get rid of electrons, it gathers electrons, it pulls it to it. So, if that's the case, for it to become an ion, then it's going to be the easiest, and it's going to work its way in this direction. So the trend of the periodic table in becoming an ion kind of depends on where we're at. So remember, here is our, change the pen color here, here is our line to distinguish what we're going to have as far as anions. And all the rest of these are called cations because they form positive. All of these here will form positive, and positive are called what? Cations. Okay? So all of these over here are going to form positive. They are going to lose electrons. And this tiny little area right here is going to gain electrons. Now, since we're only going to have to remember basically the transitional metals we don't have to worry about, we look at what it's combined with. Our main focus is just to memorize these tall columns. We will know that this tall column here is always going to have basically a 0 charge. We know that this tall column here is going to have a -1 charge. Oxygen, sulfur, selenium, tellurium is going to have a -2 charge. These top three, and that's the reason the color difference here, are going to have a -3 charge. Carbon is one that's kind of in the middle. This is where the switch comes. For your use in this class, carbon will always be a +4. But when you go to college and go to college chemistry, it can also be at times a -4 depending on what it deals with. All the rest of these down through here are going to be their +4 charge, okay? And then aluminum and boron are always a 3+ charge. All of the alkaline earth metals, which sit here in column 2, are going to be a 2+ charge. And everything in column 1, which we know is called the alkaline metals, is going to have a 1+ charge. If you can remember that, 1+, 2+, 3+, and then just go carbon is the last one, it's the positive one, and for you that's going to be a 4+, and then nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, bromine, iodine. Just remember this little group right in here as the only ones that will form negative. That will get you through this class and almost all of college chemistry before you have to start learning some of the other exceptions to these basic guidelines that nature has used. Okay? So remember, these are the only ones here that are going to form what we call anions. An anion is something that has gained electrons. It now has more electrons and protons, and all of these over here are going to form cations. And cations have now lost an electron, and it now has more protons than it does electrons. I would strongly suggest that you really have to understand what we mean by charge. It's also something we talk about as its oxidation number, which there's another lesson on, and that you need to go back over this as many times as possible until you can get this down. Remember, whenever you have questions, come in and ask so we can make sure we can keep your confusion to a minimum. Chemistry is hard, but as always, chem is try. Stay gritty out there and never, ever, ever give up.